Hi there, this is another lesson video on sequences, particularly looking today at arithmetic progressions and geometric progressions to solve real-life problems. And it comes up more often than not. For instance, this example here where it talks about 12 months interest-free credit. This is really an example of a geometric. So even though it doesn't say it's geometric, it's really a geometric problem. Potentially at least. So let's crack on and have a look at this. So a reminder of regarding formulas, arithmetics, this is the nth term formula, and you remember that A stands for the first term and the D is the common difference. So D is the common difference, how much it goes up by each term. And the slightly weird thing here is you've got, for the sum to n terms, the total of the first n terms, you've got two different formulas, and this is the one I tend to use most, but you should be aware that there is this potential for using the first term and the last term in the formula, this alternative formula. And then we have GPs, and GPs are, again, this is the nth term formula, and R now is equal to the common difference, and you should remember how to find out the common difference. So it's a common ratio, sorry, this time, and R is the common ratio, and as I say, you should be able to work it out. For instance, if you know the first term is 4 and the second term is 12 and the third term is 36, etc., etc., to find R you do 12 divided by 4 is 3, or you could do 36 divided by 12, which is also 3, as long as you do two consecutive terms. And then the sum to n terms, we've got this formula A 1 minus R to the n over 1 minus R. And there's also this sum to infinity, and that happens when R, well, technically mod R is less than 1. So if the modulus of the common ratio, so like 0.6 or minus 0.2, as long as the modulus of R is less than 1, it will effectively stop going up by very much at all, and to the point where we eventually get to it going up by nothing at all in real terms, and therefore we have a sum to infinity. So let's have a go at a question. Savings account pays 2.4 annual compound interest. I already know this is going to be a geometric problem, and because it's a geometric problem, I'm looking for an R, and the R will be it says 2.4% is added on compounded interest every time, so that's 1.024. In the same way, like 12% would be 1.12, 58% would be 1.58. You're adding on this amount of interest, and here it's 2.4%, so it's 1.024 for the common ratio. And perhaps that might surprise you that this is a common ratio geometric problem, but it is really, that's all it is. It says there's £200 paid into the account in the first year, so that's like at the start of year 1. Now if you think about it, year 2, the start of year 2, it's only actually happened once, so you would, to get from there to there, you would times, and that's almost what the common the nth term formula of a geometric progression looks like. It's AR to the n minus 1. So the nth term, you times them by R one less time than you need to in terms of the numbers. So it's not really a surprise to say that U7 is 200 times by 1.024 to the power 6, one less than the number term. And if I type that in, I get 200 times by 1.024 to the power of 6, and I get 230.58. And that's, luckily, that's what the answer says as well. So that's the first example done. Second example, Emma borrows £8,000 to buy a car with 12 months interest-free credit. At the end of each subsequent year, she's charged 4%. And she's also paying back, it says, £1,000 every year, including the first year. How much does she owe at the end of the third year? Okay, so at the end of the third year, so we've got year 1. At the end of year 1, well, she borrowed 8,000. She was no interest, so she pays back 1,000. She now owes 7,000. Easy. It'd be great if that was always the case, but unfortunately, in year 2, we now have to add on some interest. So I'm going to do 7,000. What was the interest rate again? It's 4%. So it's 1.04. I have to times it by geometric again type. Not quite geometric, because we're paying money back, and that skews it. That's 7280. And of course, once I've taken off 1,000, it will be 6280. And year 3, that'd be 6280 times by 1.04. So I get 6531.2. 6531.2 obviously is 0 because it's pounds and pence. Take off 1,000. 5531.20. That's how much I think you'd have at the end of the third year. Let ln be the amount M owes at the end of year n. Okay, find the expression for ln plus 1. Alright then, so if I know, for instance, that I owe ln at the end of 1 year, oh I see, yeah. So I would say ln plus 1, what do? Well, I times by 1.04 and then take away 1,000. That's what I've done every time. So it's ln, the amount of the loan I owe after n years, times by 1.04 minus 1,000. And it says use trial and improvement to find how long it will take for Emma to pay off the loan. All right. So basically I just keep on going, don't I? Year 4, let's do it then. Minus 1,000. Oh, I've already taken off minus 1,000. I times by 1.04 and take off 1,000. In fact, I can just use this, the fact that it does it for me automatically, and just keep on pressing, because I used answer there. I think it will work. 5792. Is that right? Have I done that right? Because it's 5531. All right, 0.2. I didn't use it right. 5531.2. Press that in, equals times by 1.04 minus 1,000. That's better. I get 4. So I'll just cross this out. At the end of year 4, I reckon it's 4752. And a bit more. A few pennies. Don't imagine those pennies will matter. I've pressed equals again. It's repeated the calculation for me. I've got 3942. Year 6, I've got 3,100. Yeah, that's possible. Year 7, it's 2224. Year 8, 1313. This is at the end of the year. Year 9, I would still have £365 left. I reckon it's year 10, and by then, somewhere in there, it all goes. Let's see what my answer says here. 10 years, good, that's right. So I'm happy with that. And the other two answers are both right as well. A job advert states that the starting salary for a job is 18,500 with an annual increase of 350. This is again another, an annual increase. It's a set amount, this. This is not geometric, this is arithmetic. If you took this job, how much would you have earned at the end, in total at the start of the 5th year? So again, year 1 is A, and that is £18,500. And I think D is 350. So, which one? It says how much have I got in total at the start of the 5th year. So I'm going to guess that this is really S5 we're doing. So, because end of 1 year, yeah, I think that's right. Is that right? At the start, I've just got to be a bit careful. So year 1, I have got the 18,500. But every year I'm earning that. So this is definitely wrong. This is the nth term it's just found. It's either this one or this one. It's S4 or S5. So I've quickly written this down. And after 1 year it's 18,500. 2 years it's 18,500 plus the £350. Third year you'd get this. So what I'm getting at is here in the 4th year you'd get that amount. At the start of the 5th year, I think it's the same as the sum after 4 years' pay. So I just wanted to think to myself about that. I therefore think it's this, assuming they done it wrong, 2A plus M minus 1D. I think that's the answer. So yes, it does say that. Now I've got a couple of real exam questions for you. Sam starts a job with an annual salary of 16,000. So you can see it's real money, real life problems, if you like. He is promised the salary will go up by the same amount each year. All right, straight away I know it's arithmetic. It does say so at the top. In this second year he's paid this, so straight away I know that D must have gone up £1,200 given these two things. Find his salary in the 10th year, well that would be U10, is A plus 9D, which is 16,000 plus 9 times the 1,200. I'll just do that on my calculator. 16,000 plus 9 times 1,200 and 26,800. It's gone up quite a lot, it seems. Find the number of complete years needed for his salary to first exceed 500,000. Well, that seems a lot of years, but if I just do this, so it's A plus n minus 1D. That's our formula. And that has got to be, well, technically greater than 500,000. So if I just add in my 16,000 to start with, plus n minus 1 times the D, which was 1,200. Did it say that for the it's his total salary? I nearly didn't get that. So his total salary isn't this formula. His total salary, the sum to n terms, and that's it's n over 2. 2a plus n minus 1d. So it's the same idea, but you've got to use the right formula because it said the word total. I thought 500,000 was a bit much, so technically I've got to go above that. So n is what we're after. 2a is 32,000 plus n minus 1 times by d, which was 1,200, is greater than 500,000. First thing I'm going to do is move the 2 over and multiply out this bracket. So the 2 is going to go over, ignore that, but then I'm going to multiply by the n. So it's 32,000, one too many zeros, n, plus n, well I've got 1,200 as well, so it's n squared minus n times by the 1,200 is greater than 1,000,000. The 2's gone over. So if I just tidy that up, I get 1,200 n squared minus 1,200 n, that's right, plus all those many n, plus 32,000 n. Was it 32,000? Yes it was, is greater than 1,000,000. So 1,200 n squared, let's do that, it's 32,000 minus the 1,200, it's just want to make a silly mistake, minus 30800 n minus that 1,000,000. It's greater than 0. So I might as well just cheat and chuck that into my calculator. So menu, it's the B button. It's a degree 2, and I want the one which is greater than 0, which is number 1. So it's 1,200 negative 30800 and negative 1,000,000. And what's it say? Well, it can't be a negative number. So what's it giving me? It's got a rather horrible number. I'm having to press. Alright, it's given me a rather nasty way of writing it, but it's basically saying that n is more than, if you can find it, 44.4. So I reckon 45 years. I haven't got the answer. So there's an additional question. I'm going to come back to this question. You're welcome to try it yourself. I shall put this on the next video, the revision video as well. So we'll see this one again. In the meantime, have a look at exercise 4H. This is a real life examples, if you like, of arithmetic and geometric sequences doing a variety of things. Hopefully it makes sense. So best of luck.